The story of artificial intelligence, it isn't this clean, straight line of progress. Not at all. It's actually much more dramatic, kind of like a cycle of seasons. You have this hopeful spring, a blazing summer of insane optimism, then a long, cold winter of failure, and now this explosive rebirth we're living through. So let's trace this incredible journey.
And it all really starts with this one simple but incredibly profound question. It was posed way back in 1950 by the legendary mathematician Alan Turing. And this question, can machines think? It didn't just start a conversation, it lit the fuse on a global race to build intelligent machines, a race that is absolutely shaping our world today.
So here's our roadmap for this explainer. We're going to journey through these seasons of AI, starting with the initial dream of the 50s, through the golden age, the winter, the rebirth, and all the way to the revolution that's happening right now.
All right, let's start at the beginning, in the spring of AI. This is a time before AI was even a formal field, but the dream, the theoretical groundwork for creating an artificial mind, was already being laid.
And really, the centerpiece of this early dream was the Turing test. Now, you gotta understand, Turing wasn't trying to get all philosophical and define thinking itself. Now, his idea was way more practical. Could we create a way to measure if a machine could imitate a human so perfectly that we just couldn't tell the difference?
The setup is brilliantly simple. Imagine an interrogator sitting at a terminal typing questions to two participants they can't see. One is a person, the other is a machine. And the goal is simple. Based only on their typed replies, the interrogator has to figure out which is which. If they can't do it reliably, well, the machine passes the test. The key insight here, it's all about behavior, not biology.
Okay, so that dream led straight into what you could call the summer of AI. This was a golden age of just limitless promise. The pioneers of the field truly believed that human-level intelligence was just a few years away. The optimism was off the charts.
And this optimism all crystallized at this landmark event, the 1956 Dartmouth Conference. This is the moment. It's where the term artificial intelligence was officially coined by John McCarthy. And look at their core belief. They weren't aiming low. They were convinced that every single aspect of intelligence, learning, creativity, you name it, could be perfectly described and then simulated by a machine.
And with that kind of belief, you can imagine the questions they were asking were just huge. They weren't just asking if a machine could play a good game of checkers. No, they were asking if it could understand language like us, if it could form abstract thoughts, if it could learn and improve on its own. The ambition was just breathtaking.
But you know how it is. Summer can't last forever. And that unbridled optimism of the golden age, well, it ran headfirst into a very, very cold wall of reality. This is when the infamous AI winter began.
I mean, the gap between what was promised and what was actually possible was just staggering. The promises were to replicate human cognition, right? But the reality was they had computers with extremely limited processing power and almost no memory. Even worse, the systems they built that worked in these tiny controlled microworlds, like a simulation with a few blocks to stack, were completely brittle. The moment you put them in the messy, unpredictable real world, they just fell apart.
There's a fantastic quote from AI experts Russell and Norvig that just nails the problem. They said the real world was just far more complex than these little toy worlds they'd built. So when the systems failed to deliver, the funding dried up, the interest disappeared, and the whole field basically went into a deep freeze.
And it wasn't just a technical problem, It became an identity crisis for the field. You had these philosophical bombshells, like John Searle's Chinese room argument. Imagine a guy in a room who doesn't speak a word of Chinese. He gets Chinese characters slipped under the door, and he has a giant rule book that tells him exactly which characters to send back out. To someone on the outside, it looks like he's fluent. Searle's point was that the computer is just like that guy. It's manipulating symbols perfectly, but with zero real understanding.
But after that long, cold winter, a new spring started to break through. And it came from a totally different way of thinking about intelligence, a fundamental shift that would set the stage for all the AI we see today.
And this is the absolute key to the comeback story, this huge paradigm shift. The old way, the one that failed, was all about experts trying to sit down and write out every single rule for intelligence by hand. It was fragile, impossible to scale, just a nightmare. The new way was completely different. It was like, forget the rules. Let's just feed the machine a mountain of data and let it figure out the patterns for itself.
And this wasn't just some academic theory, right? This new approach started solving real problems that you and I use every single day. Think about your email spam filter.
It's not following a million handwritten rules. It's learned what spam looks like from seeing billions of examples. Google's search results, Netflix's recommendations, all of it is powered by machines learning from data.
This new era had its own iconic shot-heard round-the-world moment. 1997, IBM's chess machine, Deep Blue, goes up against the undisputed world champion, Garry Kasparov, and it wins. It was this massive signal to the world that AI was back, and this time it was more powerful than ever.
Which brings us right up to today, to the current season, the deep learning revolution. This is the explosive arrival of modern AI, the one that is transforming our world at a pace that is frankly hard to keep up with.
So what lit the fuse on this explosion? Well, it was like a perfect storm of three key ingredients all coming together at the exact right time. First, the internet gave us an almost unimaginable amount of data to learn from. Second, we developed crazy powerful new hardware, specialized chips like GPUs and TPUs. And third, researchers came up with much smarter algorithms to make the learning process itself way more efficient.
And just to give you a sense of scale on that hardware point, check out this leap in computing power. We're not talking about things getting a little bit faster. We jumped from billions of operations per second to hundreds of trillions of operations per second. It's a completely different league. It's a colossal leap that unlocked things that were pure science fiction just a decade ago. And the results? Well, they speak for themselves. Today's deep learning systems aren't just matching humans anymore. In a growing number of areas, they are flat out surpassing us. From diagnosing diseases more accurately than expert radiologists to mastering the ancient, incredibly complex game of Go, modern AI has reached a totally new level.
So, after this wild ride through the seasons of AI, here we are, and we kind of end up back where we started. We have undeniably built machines that can learn and perform at superhuman levels, no question about it. But that original, nagging, philosophical question, it's still there. Is this true understanding? Or is it just the world's most sophisticated, most convincing imitation? And maybe the even bigger question is, if we can't tell the difference, does it even matter? That right there is the question that's going to define the next season of AI.